Today we're going to talk about multiplying similar square roots as well as simplifying radicals. So my goal is to get this video done between 10 and 15 minutes, so I don't want to waste any more time, so let's get after it. So if you look at this first page, so it's going to be a little bit of review. So we know when you take something like 3 times 3, it's multiplying it itself 2 times. So I could rewrite that as 3 squared. 7 times 7, I know I can rewrite that as 7 squared. 11 times 11 is 11 squared, and so on. 15 times 15 is 15 squared. If I had x times x, that would just be x squared. Now, take a look at this example down here. Here we have the square root of 7 times the square root of 7. But again, we're multiplying something by itself. And we're multiplying it by itself 2 times. So I could rewrite this as the square root of 7 squared. Same thing here. Square root of 4 times the square root of 4. Well, the square root of 4 times the square root of 4 I can rewrite as the square root of 4 squared. And this last one is already written as the square root of 12 squared. Now, let's talk about what happens when you do this. So this is kind of like opposite operation, square rooting and squaring. So the way I like to remember this is imagine this 2 is like Pac-Man. Okay, I'm sorry if I'm dating myself here. But the Pac-Man eats the square root symbol, and the square root symbol just goes away, so all you're left with is 7. Here the same thing. Here the Pac-Man's going to eat the square root symbol, and the square root symbol goes away, you're left with 4. And again, when you're squaring a square root, it's kind of like opposite operations. They cancel each other out, they go away, it becomes 12. Now, real quick, just to show you why this happens, is because let's say, for example, I've got the square root of 7 times the square root of 7. Well, the square root of 7 times the square root of 7, I can actually rewrite as the square root, put this all under the umbrella of the square root symbol, and that becomes the square root of 49. Well, the square root of 49 is just 7. Again, same thing here. Square root of 4 times square root of 4, I could put all under one umbrella, which is the square root of 16, and the square root of 16 is 4. Okay? But the easiest way to remember this is just remember when you take the square of a square root, they kind of blow each other up. They both go away, and you're just left with whatever is inside the symbol. So let's take a look at some activities with this. So here you can see on the next page, obviously the square root of 21 squared. What does that represent? Well, that just, again, these two guys are going to blow each other up, and you're just left with 321. Here I've got the square root of 18 times the square root of 18, so multiplying like items, that becomes the square root of 18 squared, which then that just becomes 18. So that would be your final answer there. So here let's take a look at Pythagorean triples. So we know how to prove whether or not something is a right triangle because a squared plus b squared does in fact equal c squared. So I can prove that right away with this first one, whether or not it's a right triangle. So 4 squared plus 8 squared equals 10 squared. Remember, the biggest number is always c, no matter where it is in the 3 numbers. So this is my c. So that's 16 plus 64, which equals 100. And 16 plus 64 is 80. And right away, this is not a right triangle because 80 does not equal 100. Okay, let's take a look at the middle one. Now, the middle one kind of looks a little weird because there's a square root symbol. It's okay. A side length of a triangle could have this number as a possible side length. We still do the same thing. Now, which one of these guys is C? Well, hopefully you realize that the square root of 12 is going to be somewhere between 3 and 4. So that is going to be less than 8 and less than 20. So this guy is my C. Okay, so let's go ahead and do this problem. Again, it doesn't matter what A and B is. So we've done these. We just got tested on that. Square root of 12 squared equals 20 squared. Okay, 8 squared, 64. And what we just learned about, whenever you square a square root, it kind of cancels each other out. They both kind of disappear. You're just left with 12 equals 20 squared, which is 400. And 64 plus 12 is 76. And obviously 76 is not 400. This will not be a right triangle. Okay, take a look at number 5. Take a look at the next one, I'm sorry. 5 squared is 74 and 7. So again, it's a little bit tough to tell what is C. What's the biggest number? Well, the square root of 74 is between what two numbers? That would be 64 and 81. So that would be between 8 and 9. So it would be 8 point something. Well, that's obviously the biggest side. So let's see if this works out. So this is going to be my C. So that means 5 and 7 are my A and B. So 5 squared plus 7 squared equals the square root of 74 squared. So that's 25 plus 49. Square root of 74 squared again, they cancel each other out. That's just 74. Let's see here. 25 plus 49 is in fact 74. So this one would be a right triangle. Okay, so again, we're using the procedure of squaring a square root to help work through one of these problems. So let's take a look at some examples on page 63. So this is the puzzle page. You don't have to go to the puzzle right now. You can just kind of pay attention to the video where we're at. And I'm only going to do the ones that have a radical symbol because we should already know how to find C in these problems because we just got tested on it and we've done plenty of practice problems. So let's take a look at number 4. So number 4, we're trying to find our hypotenuse, which is C. So again, a squared plus b squared equals c squared. So I'll just write that up here. So a is 7 squared, b is the square root of 20 squared, and c we don't know yet. So we're trying to find that out. So that's 49 plus the square root of 70 squared. We should already know that cancels each other out. That's just 70 equals c squared. 49 plus 70 is 119. I think I'd be a little faster with that. Equals c squared. And then finally, the last step of any Pythagorean theorem problem is to take the square roots. So the square root of 119 is 10.9. So either the square root of 119 or 10.9 would be the answer here. Okay, let's take a look at another example. Let's do number 11. 11 has the square root symbol as c. No big deal. So we don't know what a is. So we are going to have to solve for a. So let's do c squared minus b squared equals a squared because we're looking for a leg, so we have to subtract. So we're going to subtract our hypotenuse, which is the square root of 70 squared minus 6 squared. And we don't know what a is, so we'll leave that as a squared. So again, square root of 70 squared, they kind of cancel each other out. They blow each other up. You're just left with 70 minus 36, which equals a squared. So 70 minus 36 is 34, equals a squared. Last step in a Pythagorean theorem problem is take the square root. So square root of 34, some of you should be able to estimate that. And that is 5.8. So 5.8 here would be A. So which problem was that? 5.8. Okay, so that would be how to do page 63. Again, just remember taking the square of a square root. These guys just kind of cancel each other out. You're just left with whatever's inside the symbol. All right, let's move on to the next topic, simplifying radicals. So, simplifying radicals is kind of like getting out of jail free card. So, basically what I mean is this radical symbol. Imagine this radical symbol here is like a jail, and these numbers are trying to escape. And the only way these numbers get to escape is if they are a perfect square. That's it. If they're not a perfect square, they're not going to be able to escape. So, let's take a look at this. So, for example, the square root of 49. Now, we should know that 49 is a perfect square. And remember, this symbol is asking what number times itself is the number inside the symbol. Well, 7 times 7 is the number inside the symbol. So 49 gets to escape the radical symbol. That becomes 7. 81, again, you guys should be familiar with this now. We know that what number times itself is 81 is 9. So notice how it gets out of jail. And then finally, the square root of 196, 14 times itself is 196. So these all get out of jail. And again, these are ones you should already know. You're not learning anything new here. It's these guys down here in the red that are a little bit different. These are not perfect squares. At this point, you can't get out of jail. But what you can do is you can actually manipulate these numbers so that they are perfect squares, and then they get to escape. The only catch is not everybody gets to leave jail. Some people do have to stay in jail. So let's take a look at this. So here I have the square root of 75. And what you have to do with these problems is you have to think about ways to break them up so that maybe one of the numbers is a perfect square. So what you can do is ask yourself, what number times, or I should say, what factors give me 75? In other words, what numbers can I multiply to get to 75? Well, the first thing that comes out of my mind is 3 times 25. Okay, 3 times 25 is in fact 75. Now, one of these guys gets to leave jail because one of these guys is a perfect square. So hopefully you can see which one that is, and that of course is 25, because square root of 25 is 5. So 25 now gets to leave jail. Now, when it leaves jail, it becomes the square root of 25, and the square root of 25 is 5. So when he exits jail, he's now a 5. And unfortunately, the square root of 3 does have to stay in there. It cannot break down any further. So that would be our final answer there. Okay, take a look at the square root of 90. So there's a couple ways to break this down. Square root of 90, I could do 3 times 30. I could do, let's see here, 2 times 45. Okay, but the one that kind of sticks out that I noticed right away is 9 times 10. Okay, so 9 times 10 is 90, and I know right away one of these is perfect square. So I like when I can factor it into a perfect square. So 9 is a perfect square. I know the square root of 9 is, it escapes jail, and when it escapes jail, it becomes a 3. So that would be 3 times the square root of 10. And unfortunately, 10 cannot break out of jail because I can break that down into 2 and the 5. And unfortunately, none of those are perfect squares. It's got to remain in jail. So this is as far as I can take it. Okay. And then take a look at this last problem here. I've got the square root of 200. So again, I want to break it. There's many different ways I can break 200 down. For example, I can do 4 times 50, things like that. There are more, but just at the same time, like I said, I'm going to go right to one that I know right away. So when I think of 200, what two numbers come together to create 200? I think of 2 times 100. Okay? And one of the more famous perfect squares out there is the number 100. So 100, as soon as I see 100, I'm like, oh, that guy's escaping jail. He's good. He's getting out of there. So the square root of 100 we know is 10. And unfortunately, 2 is not a perfect square. He's got to still stick around, so he's got to stay there. And this would be your final answer here. Okay, so this is what's called simplifying radicals. It's just kind of factoring these numbers into perfect squares so they can escape the square root symbol. So that's why I have this get out of jail free card from Monopoly. Okay, so let's take a look at some examples here. I'm not going to do all of these, but let's just take a look at some of them. So take a look at letter L. Is the square root of 8. So not a perfect square. But think of the factors that come together to make 8. This one should be fairly obvious. 2 times 4. And unfortunately, only one of these numbers gets to escape jail. So that would be the 4. So the square root of 4 is 2. Again, can't do anything with the other 2. It has to stay inside the jail. So this would be the final answer here. And let's see here. So that would go with that. Let's take a look at another one. How about the square root of 45? Let's do I. Okay, and again, just think of numbers that break down into 45. Again, the better you are at your times table, the faster this goes. If you have to keep going to your calculator on this does take a while. But if you know your times tables, this does go rather quickly. So 45 is 9 times 5. And bam, I nailed a perfect square. It's always good when you hit that perfect square in the first try. So the square root of 9 I know is 3. So that gets to escape. And remember, when it escapes, it does not become 9 times square root of 5. Because once it goes through the jail, it transforms to its square root. So that would not be correct. So it becomes its square root version, which is 3 times the square root of 5. And again, 5 has to stay. It's not a perfect square. So let's see here. Is that hopefully one of my answers? Yes, that comes down here. 25. All right, let's go through some more colors. About A, square root of 50. So, again, you could think of 5 times 10, but neither one of those are perfect squares. There's one that pops out right away. That would be 2 times 25. And one of these is a perfect square, and you guys should recognize which one it is. It's 25. It gets to escape, and remember, as it escapes, it then becomes its square root, which is 5 times the square root of 2. So that would be this one. Okay, moving on. Let's see here. How about square root of 12, t? Okay, again, square root of 12, I can break that down into 6 times 2, but neither one's a perfect square. Oops. Let's try another. Let's do 4 times 3. Okay, I like 4 times 3 because one of these is a perfect square. The 4 is, it gets to escape. The 3, unfortunately, has to stay behind. So that would be 2 times the square root of 3. Okay, so right there. Done. About square root of 98. Do this as this will be our last one. Yellow. Yellow doesn't show up too much. Let's pick a different color. How about purple? Okay. Square root of 98. So think about breaking down square root of 98. Obviously, if it's even, you can divide it by 2. So let's see here. 2 times what? 49. This one actually may work out. So one of these is a perfect square. And you got it. It's 49. So as it escapes, you got to ask yourself, what's the square root of 49? Well, that would be 7. 2, unfortunately, not a perfect square. He's got to stay in jail. So let's see here. 7 times the square root of 2. Okay? So that's how you simplify radicals. Okay? Try to break them down into perfect squares as best you can. Okay? Now, one I do want to talk about. Let's talk about A real quick. This will be the last thing we do. So square root of 50. So I could have broken it down another way. I could have said, okay, well, that's 5 times 10. Well, 10's not a perfect square. But I can keep breaking down 10 further. I could break that down as 5 times 2. Well, now what you should notice is, oh, I've got these two 5s here. I can multiply these together and really get 25 times 2. Now I've got my perfect square. They can escape. That's 5 times the square root of 2. Or if you ever see two numbers alike being multiplied on the inside, that's a big clue that they get to escape. Okay, they're going to escape the square root symbol. So just in case you factor it down into two numbers that are not perfect squares, see if one of the numbers can even break down further, like I broke this 10 down, to get my perfect square. Okay? All right, so follow your instructions in your teacher's folder as to what to do from this point forward. Just if you have any questions, again, either send me an email or Zoom on in or ask one of your teachers. All right? That's all I got. Have a great day, everyone.